This lesson is on exponential functions, and the first thing we're going to look at is how to graph. Okay, so what makes this an exponential function is that x that's in the exponent spot. Okay, so when you have an exponential function, since we don't really know what these look like to start with, we're going to make a t-chart and plug some points in to be able to come up with a graph. So let's try like -2, -1, 0, 1, and 2. So that way we have some negatives and some positives. If I substitute in -2 for x, then that means my y is 2 to the -2nd. When you put that in your calculator, it's going to tell you 0.25. And then 2 to the -1 would be 0.5. 2 to the 0 is 1, 2 to the first is 2, and 2 squared is 4. So I just substituted all of these x's in here, just like I did for 2 to the -2. This is 2 to the -1, 2 to the 0, 2 to the first, 2 squared. Okay. So you could substitute those in on your calculator. And then when we make our graph, we're going to graph -2 and then 0.25. So there's -2, 0.25 is about right there. -1, 1/2 is about here. 0, 1, 1, 2, and then 2, 4. And so an exponential curve looks like this. Now you can also put these in your calculator. So I'm going to show you how to do that, and then you can also get this t-chart that we made off of your calculator as well. So when you go to your calculator, you go to y equals, you type in 2, and then your little caret top that's right above the divided by key and right next to clear, and then your x, which is right next to your green key. Okay. So when I hit graph, it looks like this, and my screen is a little awkward, but if I turn it this way, maybe it looks a little better. Okay, so that's what an exponential graph looks like. If you notice, it starts out really slow, and then all of a sudden it turns and starts to shoot up. Now, if I hit second table, then there's the t-chart that I just came up with. So you could either copy down points from the t-chart if you didn't want to plug them in. That's fine. But that is the basic shape of a exponential curve. Now, you've seen a lot in these past 4, 5, 6 weeks now about the coronavirus and the fact that, one reason they canceled school and shut the whole world down basically is because they were afraid of the spread of the disease, because this disease grows exponentially. And so they didn't want there to be a big spike like what you're seeing right in here. Okay, because that would mean more people would get sick. So when they're talking about flattening the curve, this is the part that they're trying to flatten. They don't want it to take that exponential shape. They want it to be flatter. That way you don't have this many people way up here getting sick. Okay. Now, we will also be solving equations that are exponential. So, for example, let's say we want to solve each, and we're just going to look at some basic equations since we're kind of running out of time here. But let's say we have 2 to the x equals 8. So you want to know 2 to what power equals 8. So you can use your calculator and kind of play around with it. Try 2 squared, 2 cubed, 2 to the 4th, so on until you get 8. Okay, or if you like to solve things algebraically, You could also say 2 to the x equals, and then rewrite this side as 2 to a power. So 8 is 2 to the third. Okay. Well, since these bases are the same, they cancel out, and so you're left with x equals 3. And sure enough, if you were to check on your calculator, 2 to the third is 8. Now we're going to focus on a few applications of some exponential formulas, and both of these formulas are going to be based on money. So this first one is to find compound interest. So if you have A equals P times 1 plus R over N raised to the NT, that's the formula for compound interest. A is the final amount. P is the principal, or the starting amount. R is the rate, but you're going to write your rate in decimal form. N is the number of compounds. And that's per year. And then T is your time. And usually your time is in years since your compound is in years. So that's our formula for compound interest. So for example, let's say that we want to find the amount in an account with an initial investment of $1,500 at 9% for 3 years. And we're going to say this is compounded quarterly. That's a terrible percent sign. Let me fix that. Okay, so we want to find the amount in the account, so that's going to be our final amount. So we're solving for A. And then when I look at my formula, P is our initial investment. So I put in $1,500 for P. And then 1 plus my R is my rate. 9% would be 0.09 for a decimal. So remember to change a percent to a decimal. You move the decimal 2 places to the left. So it's like a 9, so it's like 9.0. So you're going to move it 2 places. So that makes it 0.09. And then I divide by N. N is the number of compounds. Well, if it's compounded quarterly, what do you think quarter means? Yeah, just like money. There are 4 quarters in a dollar. There are 4 quarters in a year. Okay, and that's to the N times T. And our T is 3 because of 3 years. So that's how you substitute everything in. And so now you should be able to just put it in your calculator just like you have it written. So we'll pull our calculator up. I'm going to quit to go to my calculation screen. I type in 1,500 parentheses, and then 1 plus, grab my fraction, I have 0.09 over 4, close your parentheses, and then use your little caret top for your exponent like we did earlier when we were graphing. And it is to the 4 times 3. And there it is, $1,959.07. So if there's $1,959.07 in the account, how much interest was earned? So you're going to take 1959.07 and subtract 1,500. Whoops, don't need the 1 there, do I? So $459.07 was earned on that account. All you had to do is leave it in the account for 3 years and not spend it. Now, the other formula we're going to talk about has a new number that you may have seen in Algebra 2. I know sometimes some Algebra 2 classes don't get to it, but let's talk for just a second about the number E. Okay, E is called Euler's number. It was named after the mathematician years and years ago who figured this number out. But basically, I'm going to show you where that is on your calculator. Okay, you actually have 2 places where it's located. So if you will look on your calculator screen, do you see the divided by key? If I look above that in blue, I see an E. So if I hit second divided by, there's E. So E is about 2.718. Okay. Now you also have it right next to number 4. There's a key that says LN. And above that you see e to the x. So if you hit second ln, you get e, and it automatically puts that exponent there. So if you're raising e to a power, you don't have to hit the caret top after. So that saves you a little bit of time. If I just want to know the value of e, that's like e to the first. Okay, and once again, we get the same number, 2.718. So the number e is about 2.718. So on this example, just to practice using your calculator, number E, we want to evaluate. And for A, we have e to the 2.7. And for B, we have e to the negative 3.2. Now, for both of those, I have an exponent on the e. So the quickest way to do the problem on my calculator would be to use the E at the LN button. So if I hit second LN, then I can just type in 2.7. And so E to the 2.7 is about 14.88. And then if I want to know E to the negative 3.2, I type that in. It's about 0.04. So that's how you use your E button. Okay, now that we know that, we're going to look at a formula with E in it. This is another compound interest formula, but this one is for interest that's compounded continuously. Okay, so our key word is continuously. When you see that, you're going to use this formula. So the A still means the final amount, just like it did in the last equation. P still means initial amount, just like we said before. R is rate as a decimal, and T is time in years. The difference is the E, okay, but that's our new number E that we have a calculator button for. So what's the difference in interest that's compounded continuously versus what we saw earlier where we had to tell it how often it was calculated? Like the problem we did was quarterly, or you might see a problem that says annually. Okay, well, if it's compounded continuously, that would be like having an N value of 365 or more. So your interest is figured out every day. Okay, so we're going to take that same problem that we saw earlier, where we want to find our A, and our P was 1,500, our rate was 9%, and our time is 3 years. Okay, so we're using the same numbers that we had before, only instead of our problem being compounded quarterly, we're compounding continuously, so we're using this formula. Okay. Now, what do you think? Should we end up with more money than the $1959.07 we had before? Or should we end up with less money than the 1959.07? Okay, so be thinking about that while we work through this and see if your guess was right. Okay, so that's your setup. I put in my 9% is 0.09 again, and then 3 for years. So now when we enter it in our calculator, we should be able to do it all in one step. We're going to type in 1,500 E, and I've already got my exponent, so it's 0.09 times 3. Okay, so look at our answer, 1964.95. So were you right? You should end up with more money, shouldn't you? If you're getting interest continuously as opposed to just 4 times a year, then that means you're making interest off of interest quickly. Okay, so it's not a whole lot more money, but a few dollars. Okay, and over a longer term than 3 years, it would be even more. So this one is 1964.95. And that's our money. Okay, so that's all we're going to cover on this exponential functions.